Good morning, guys. Can you hear us? Perfect.
Awesome.
So thank you very much for showing up. We know it's early. It's 9 a.m. I'm barely functional, so we feel your pain. Thank you very, very much for showing up.
All right, let's get this show on the road. So hi, folks. Welcome to Florian and Sam Make a Real-Time Strategy Game in Fortnite, where we're going to explore this sort of mad thing that we did. That we don't regret at all. And before we get into that, let's introduce ourselves a little bit. So who are we?
Yes. So hi, my name's Flo. I'm with Epic for 7 years now. For the purpose of this call, just pretend I'm a technical artist. And this is also where just our whole perspective is coming from, right? Neither of us is a developer. So that's what you need to know for this call, because that's also how we approached everything. So very important to know.
And I should probably start our timer. So I'm Sam. I'm a senior tech designer at Epic Games on the technical content team. So I make the new templates that came with 5.6, samples like Stackobot, Project Titan, example projects across Unreal Engine and UEFN. And prior to that, I was a game designer for about 25 years across AAA, indie, VR, mobile games, all kinds of stuff. But notably for this talk, I made a series of relatively big ticket real-time strategy games and have a lot of experience with that genre, which is kind of where this talk came from, with Florian going, hey, we should do that. And me going, okay, I guess we shall. So to kick things off, let's talk about the core design of the thing that we built. Here is our agenda. One thing I want to sort of get across early is, because we only really have 40 or so minutes to do this, there is no way we can go into all the details of everything we did, simply because that would be a seminar. It would take days.
Yeah.
So instead, we're going to take you through, do our best to take you through how we did things, why we did them that way, and you can do the same. And then if you want to go into more depth on anything, we'll be on the booth at the UEFN booth starting at, I think, 11.
Yes.
And we have the project there. We can open up a verse. We can take you through all of that and show you in more detail how we did any of these things we talk about today. But we want to get through the whole thing, so we don't want to just watch me live debug my verse on camera. It doesn't seem to be that fun. All right, so what is a real-time strategy game? That is a good question. Hopefully you know since you came to this talk, but maybe you don't. So an RTS, which is a genre I've worked in a fair bit, is defined by a couple things. It has an omniscient view with a free-roaming camera, meaning unlike things like Fortnite, it is not tied to a player character. You are not controlling a character. You're instead controlling, as I put very dramatically on the slide, ravening hordes of units. You control them with group selection, and then you support them with structures, which means production structures, which build the units, and resource structures, which you pay for them with. And usually there are secondary, tertiary structures as well. So we have a couple of those, mostly our player base, but that's sort of the heart of it. Then there's game balance, which I refer to as the combat triangle, which is really sort of rock, paper, scissors, light units that move fast, don't take much damage, don't put out much damage, are good for scouting, medium units that are somewhere in the middle, and then heavy units, slow, do a lot of damage, take a lot of damage, and usually you balance those three against each other to build out your core strategy. And then finally, well, there is a lot of really good campaign content in an RTS. It is a primarily multiplayer-driven genre, and that's what we built here, is a two-player multiplayer game. So to further illustrate our point, I'm going to run a little trailer for you with rocking music. More later. Got to get you queued up a little bit. Yeah. So we will have there's a much longer version of that we will show at the end so you can see more of what we built. But this gets the idea across of what we made. So at this point, I'm going to hand over to Florian to discuss why we used UEFN.
So primarily because just multiplayer just works, right? It's built in. We don't have to care for that, because honestly, if you would build that from scratch, we see each other again in 18 months, right? So it's really good for rapid prototyping. It's really good for trying out games and just see if your game sucks, right? And funny enough, it doesn't suck. So we actually had fun playing the game, which surprised us. So that's good. But also it's about testing, right, and deployment. Especially for me, originally I'm coming from the enterprise side. And it's just so amazing to see your own game on your stock console, right? It's just mind-blowing. And it's just so seamless. It's so easy. Also, again, devices save just a ton of work. There's so much that is already built into Fortnite, which you can just leverage. And we did, and we will show you how. But also, it's about future-facing technology. Obviously, Verse. Again, I'm not a developer. Verse is literally the only language that I'm able to do anything in. And what helped us a lot is honestly the Epic Developer Assistant. Because again, not a developer, so syntax is, why is there a bracket? I have no idea. The Epic Developer Assistant solves that for you. So it's super helpful. So yeah.
Okay, so next we're going to talk about how we implemented this thing. And we built this over like about a 4 or 5 week period leading up to this talk, because we wanted to kind of do the UEFN thing where you build quickly, you develop rapidly, you iterate. So implementation, from turning a third-person shooter into the thing that we showed you before, which is definitely not Fortnite. So first thing we did is we needed to create a custom game loop, because Fortnite's game loop is very specific to lobby-based third-person shooter games, and that is not what we're making. And fortunately for us, some very nice people in the Epic developer community, people who work for Epic, created boilerplate code for creating a custom game loop. And there will be a QR code at the end of this with links to all that stuff, so you don't need to write down that URL, take screenshots or whatever, it's fine. But we basically used this really nice boilerplate code to create a custom game loop. So we have a pre-game where you essentially can scroll around the map. You can't build anything, you can't interact with anything, but you can kind of scout out the map while the game is being set up, other people are joining, and so on. We have our main gameplay loop where we turn on things like our UI, where your UI, our interface, our combat, all the visual elements of play, and also enable a lot of stuff that's running in the background to make sure that the gameplay actually works. And then we have a game over phase where it ends the game and cleans up after itself. And you can take this code a lot further than we did. You can create multiple kinds of mode, you can create multiple rounds within each part of the phase, and so on. We didn't need to do that, but you can. And so if you're interested, take a look at the boilerplate code from the EDC. It is not that documented, but it is really heavily commented, so it is useful. So what is next? Oh, the camera.
Yes. So, obviously, this is very different in Fortnite, right? The way you control it and the way you just interact with it. So we did have to just create everything from scratch. We are using the fixed angle camera and the third-person controls. And I will actually show you in editor how we started that, or how that works. So, oh, this is very small. So, camera. Just bear with me. This is everything that we have in controls. So it's a lot, but let's break that down. So the core of everything is this little proxy, a camera proxy, and it's actually, we choose the trash can because it's lean and small. And this serves as the center of our of the screen, basically, right? That's also our mouse clicker, our mouse pointer, and so on. And it also determines later on where the units are walking to, so you have all the control. We used, as I said, we're using the fixed angle camera device. And the important thing is here, so what you can do is you can have the focus target override, which means we can choose our camera proxy and can say, camera, follow this proxy, don't follow the player. The player is actually underneath the floor, underneath the map. And we did, because we didn't want to put the player just in a box, because it's always a little bit, it's just not that great. Also because things can go south. So we put the players in stasis, so that you can't move, you can't rotate, right? Nothing can happen to the player. And we are using a device to control that, which is somewhere. Yes, where's camera logic? So as you can see, we have 2 of those, and Sam will go into a little bit more into detail with our utils device and so on. But basically, we are choosing the player, And we're identifying the player, and then we have all those input triggers that we're utilizing. So WASD, right? Or on a controller, it's the left thumbstick. So it feels a lot like N64 Command and Conquer was my base. So and that's kind of what we try to build here. So it works on every device, and it's also comfortable on a controller and so on. So I don't want to go into the verse code. You can come later if you're interested in that, just because it's not great content. But essentially, when you press W, right, or with your thumbstick up, the camera is moving up. If you press left, it's moving left, and so on, as you saw before. We also have a zoom function. We will go a little bit into detail later on, but essentially what it's doing is just moving the device up, right? And we are adapting all the stuff later on. As you can see here, player index, right? And this is where you are coming in again.
Oh, me.
That stuff.
Hi. Okay, so
let me go back.
Yeah, there we go. I don't want to accidentally advance a slide in the Unreal Editor. Who knows what will happen there? Okay, so let's talk about unit selection. User interface is a huge focus for us, obviously, with a game like this, because an RTS is inherently user interface driven because you're not controlling a player. You're basically using an UI to drive your game world. Players need to group select and move units. They need to select production structures, add more units to their build queue, which is how units are built, and then check their resources to make sure they have necessary credits. For unit selection, we went with what I think of as a console-style methodology, which you can see in this video. Meaning what you're doing is you're drawing a 2D box from the center screen, and then when you release, you basically hold input. When you release it, whatever the size of the box is, we translate that from 2D to 3D, and then select all the units in the box. And the reason we did this versus your traditional sort of RTS drag select is because we wanted this to work across all platforms, not just on PC. So it works on your phone, it works on a console, it works on PC, it's always the same interface. And how that works is we use two verse devices, one to draw the box, and then the one that takes the dimensions of that box, identifies units within its bounds, and selects them. And the first is quite simple. It just uses verse UI to draw a scaling box. When you hold in the button, runs a loop that starts doing that. When you release it, it finishes, and then sends the bounds of the box, translated from 2D to 3D, to the actual unit selection device. So the translation from 2D to 3D, people go, how did you do that? And I said, by entering numbers until I got one that worked. Because the reality is 2D to 3D conversion is very complicated, and the answer is multiplying it by 650 for some reason. I wrote a debug tool that would draw the 3D box, and then I just kept iterating until it worked. So this took a fair bit of debugging.
And we also had a funny situation where we like selecting each other's units and stuff like that.
Controlling each other's camera. One of the things we do a lot is we basically use the player index, the player team number, to drive a lot of our logic. So player 1, which is team 0, because of the way array, player 1 is actually team 0 inverse because of the way arrays work. Player 2 is team 1. There were definitely no bugs caused by me getting those numbers wrong. But we use that to drive a lot of that logic. So there is actually only one verse selection device, and I can hop over to the editor for a second and show you. Let's find the selection device. Verse selection box. So this is the thing that draws the box. It just takes an input trigger and runs some verse. I will show you the verse at the booth. I'm not going to do it here because nobody needs to watch me scroll through Visual Studio Code. And then the actual selection logic is here. And what that does is it uses the camera proxy point, so it knows where you're selecting from, so it can extrapolate 3D box from there. And it uses something called the NPC tracker device, which is pretty standard real-time strategy game methodology. What you are doing is you don't want to go, hey, let's raycast everything in the box and see what's in it, what's not, because that's not very efficient, and especially in UEFN, raycasting can be very complicated. Florian will talk about that more in a bit. So instead, with the NPC tracker device, I'm simply keeping track of what units exist in the world and who owns them. And then I can simply iterate through that list, basically go, NPC tracker device, player 1 has drawn a selection box. What units do they own? And then I find the units that are in the bounds of that box, and I put them in an array and says player 1 has these selected, and that's what we use to run commands on the units. And then We also have structure selection, which is actually simpler, because what we're doing there is you just hover over the structure. And that activates the structure UI, which is a 3D billboard with text. If I scroll over a little bit, I can show you that. So you'll see this. You see the billboard there. It says selected, and that is a billboard with dynamic text. When you scroll over the structure, what we're actually doing is we are running a loop in the selection logic that checks against a box that's an arbitrary size that we draw around the player cursor. And again, we have a list of production structures, just like we have a list of units. When you use the input for the production structures, of which there are 2, and I'll get into that in a sec, what you're actually doing is going, okay, which production structures do I own that I am hovering over, and then run the production structure logic on those structures. And so that's how selection works. It seems like it would be very complicated, but it was actually one of the less painful things we had to do. And so I'm going to go back to the slides and hand over to Florian to talk about the most important thing in a real-time strategy game, which is units.
So initially we wanted to start out with really like custom units, right? Full custom units, but we just quickly realized, hey, we got like 3 weeks left, and I can't, because that it means you need to really start from scratch, right? All the code, all the behavior, but not just that, also just the way the character looks, right? The animations, the skinning, the rigging, just everything from start, and we were like, yeah, not gonna happen. So we went in there, looked like, okay, how far can we actually get with the NPCs that are already here? And the answer is actually quite far, surprisingly. There are a few limitations that we had to work around, but for our purpose, it worked really well. One thing you have to know upfront, it's limited to 90 NPCs. And Sam, I think you will go into detail a little bit more about how that, like what we did in terms of caps and so on. But essentially, you can't go over 90. I had a battle of 45 against 45, which surprisingly worked, which is great, but you can't go over that limit. So the key of everything, and going back to the editor, let me see, browser. So we call it Project Snowball. So we have different behaviors set up, and one behavior and 6 different definitions. The way they differ, again, as Sam said before, we have different unit types. So it's mostly the difference is mostly modifiers like how they look, right? Which weapon do they have? But also like health modifiers and so on. The other thing that is like super important was the whole awareness and guard perception modifiers, because obviously you don't want your units to attack units that are like on the other end of the map, right? You want to have control over that, and with that, was pretty nice. So what we ended up doing was we started out with the guard type, and then created our own verse behavior on top of that. And again, if you want to see the code, no problem. Just come to the booth. But essentially, so how this works is, I'm getting a list from Sam, again, the list that he was just talking about. And NPCs.
This is what happens when you let me organize all the devices.
So we have our NPC tracker, right? And then we have an NPC walk manager device. I'm sorry for my naming. Again, not a developer. What we use is the input trigger, which is the left mouse button, because I need to tell the NPC navigate to this and that position. What we're also doing is when the NPC spawns, we are setting a leash position at the spawn position. So the character, because Fortnite NPCs tend to wander off into the wild, and you don't want that. So it's all about the leash position and the leash radius, inner radius and outer radius, which you can define in that device. So, and every time we're clicking with the left, so the way the loop works is basically we're checking is a unit selected? That also means, because I only can select my units, I don't need to worry about that part in my behavior, right? I don't need to check is this my unit or is this his unit, because I can only select units that are already in my list. And I'm taking that list, I'm getting that list from his devices, and then on left mouse button, the selected unit is just walking where the position of the mouse center is. And we're setting the leash position there. And that's pretty much everything that we did in this one. There's a little bit more in here because I'm also controlling the mouse cursor animation, and it's just a sequence. I will come back to that little, like the visual part later on, and I will explain that later. But yeah, that's about it for the NPCs.
Oh, and back to me.
Yes.
Oh, what was I going to talk about? Okay. So the next thing to talk about is the other key building block of RTS, which is structures. And these are, like, again, a key building block of RTS gameplay. And for our game, we went with 3 structure types. So there is the player base, which is when I said there are tertiary structures, we have one. It's the player base. It's the ultimate focus of any match, with each player defending their base and attempting to destroy the enemy's base. That's how you win, that's how you lose. These are actually quite simple. They're an UEFN objective device with a custom mesh and some nifty destruction effects. I'll show you how that works in a second, driven by Sequencer in a little verse. As an aside, many thanks to Andreas Brock for our very nifty structure art, because he was the one that did that. Do not credit us for the art. He's very talented. So I'm going to actually show you how these structures work. So as you can see, it is a creative device where we have basically put a custom mesh on it, and then we have some sequences. I'm going to find our destruction sequence. It's got to be in here somewhere, right? Let me see. There we go. Destruction.
Yes. That's my part. I'm sorry for messing that with all the structure.
As you can see, like, Florian created this 10-second long sequence where the structure can be destroyed, start spawning VFX and all of that. And what we're actually doing is we are using the cinematic sequence and we're driving it through verse, but it's very simple. The structure has 1000 XP, or HP rather. The sequence is 10 seconds long, so they're easily divisible into each other. As the structure takes damage, we just jump forward in the cinematic sequence until eventually it blows up and you win. So let's you do structure destruction that is based on player input versus just running a sequence. You can control the sequence through a sequence device. It's one of the nice things about UEFN. So the next thing up is the resource structure, which provides a regular resource tick to the player. So I'm going to scroll over to our resource structure. And so I hit the wrong key. All right, so let me close sequencer and talk about these a little bit. So the resource structure, the whole thing in an RTS is you get a regular resource tick from any resource structure you control. And this is driven by verse. Each player has 2 devices. So if I go into resources, there is the actual structure device is a thing. It's probably in there somewhere. Yeah, there he goes. There is the resource tick device. And what that does is it basically just runs a loop based on who controls it. If no player controls it, it doesn't run the loop. And it says every 5 seconds, give the player X amount of resources. And you can see here I am referencing both the various props, but also the value of resources you get on the tick, and the resource managers, which are the 2 devices, there's one for each player, that track what resources you have. These are verse devices that are very simple. All they do is go, you have this many resources, and display it in a UI. Like if I jump back to our slideshow, it'll actually show up in the video. So you can see that the bar up here is your resource amount. That ticks up, it ticks down. There is some very nifty animation. You can see the harvester running there, collecting resources. That's actually totally unsynced to the tick. It's just there to look nice.
Yes, it's just visual.
And then with the resource manager, we can use it's basically how we track how much money you have. So when you go to build units, this is my nifty transition to production structures, we can go, does the player have enough money to build this unit? So it's simple. I'm happy to show you the verse code for it, but it's basically a loop and a function that's called that says update resources. And I'll talk a bit about what happens when a resource structure changes between players when I get to the next slide. Okay, so what do you use those resources for? We use them to build units, the little things running around that we were just talking about. So that's a production structure, which you can see in this video. It'll look back there again in a second. They provide a selection of units, 3 types of units, which we have right there. That is a production structure, 3 per player. And that means that you can go there and using the on-screen UI, you can do 2 things. You can toggle between the type of unit you want to build and you can build a unit. When you do that, we go to, hey, Resource Manager, can we afford to build this unit? And you can put them in a build queue. I will talk about how the build queue works in a second. And each time it's about to build a unit, it goes, can I afford that? And if so, it builds a unit. It takes a set period of time to build the unit. And I'm going to talk about how that actually works from a production standpoint in a second. But first, I want to talk about how you control structures, because we had to do some compromises there, but it's worth talking about the setup. So we went with a structure capture system for our game. Many RTSs focus on building the structures yourself, but given our time limits, we wanted to keep things a bit simpler and a bit less fiddly, because that's an immense amount of work and we only had so much time. And it also makes it just easier to play for people who are more entry-level gamers, so it was the system we went with. And the capture logic is conceptually quite simple. You can see it happening here. Basically, a production structure starts out uncaptured. You can see it is white. And then when a player moves units into the radius of the structure to initiate a time capture sequence. Once that timer completes, the capturing player takes control of the structure itself. And if the player's units leave the zone or are destroyed before the timer completes, the capture sequence is cancelled out. The captured structure can also be captured by another side. Once you own it, doesn't mean it's yours forever, though there was a bug where for a while it was yours forever. Moving on. As I discovered and then exploited so I could beat Florian. But yeah, so you have to defend your buildings. So how this works is a mixture of devices and some verse code. All right, so what we do is we use a mutator zone device, a timer device, and whatever structures we actually capture. They are all referenced by something called a structure capture device. Because what we didn't want to do is build the capture logic into each device or into each structure, because then you have a lot of redundant code. So this is just good UEFN practice, is you build a structure capture device, in our case, that has all the code. It handles the mutator zone, it handles the timer, and it contains a list of the structures you can capture. And what we do is once the timer has completed, we have a list of the structures that can be captured by that particular capture device. It's usually 1, can be more. And we send an interface call to that structure that executes an interface command, a function essentially that we have an interface called capturable. And if you are capturable, you'll be able to execute a function that says, I've been captured by this player. And that contains what bespoke logic we have. So I'm trying to show you the video. We'll do it. There we go. So mostly what that does is it does things like setting the material instances. So you know who controls a structure. We have different colors. See, it turns green because player 1 captured it. Sends that HUD message. And then if you're a resource structure, it activates the resource loop for your resource tick. If you're captured then by a different player, we shut down that loop and relaunch it, pointing at the other resource manager. Production structures, what it does is it basically says you are controlled by this player. We must activate these spawners because we use spawners for the actual production. So it turns on the basically logic of the structure when you capture it. If it's captured by a different player, we run that logic again and set it up for the other player. And that is structure capture. So moving on from there, before I ramble too much, let us talk about how production actually works, because this is one of the most complicated things that we built. What we have is, it's driven by verse. We use 2 input triggers to control our production structure, toggle unit type and build current unit. When a player presses either, the production structure checks to see if it's controlled by that player. And what we've done is we've built a function library called RTSUtils that can basically get a player's team from a player or an agent, because we do that everywhere. So we just built it as a function library. And all throughout our verse code, when we show you our verse, you will see we are just going, okay, so when an input trigger is fired, it passes on an agent. We go, which agent is that player, does that player belongs to which player? And in this case, if it's the same as the player that controls the structure, then we take those inputs and apply them to the structure. but they also have to be in the hovered state, which I referred to before. So you have to be hovering over the structure and own the structure to initiate production. And so that runs the appropriate functionality. So toggle units is self-explanatory. It literally we use an integer, starts at 1, moves up to 3. Each time you toggle it increases. Once you go over 3, we reset it to 1. Each one corresponds to a specific unit type, which is used to update the structure's build UI, which is that billboard device right there. And the text is dynamic, which is really nice. And then if you press the build button, we add that appropriate unit type to the build queue. So how does the build queue actually work? Well, each time you tell a structure to build a unit, we don't actually build it directly. What we're actually doing is running a regular loop that checks against the build queue and says, is there anything in this build queue? The build queue is just an array of integers. And if there is, what we do is we take the first entry in the array, and that is the unit we're going to build. So we remove it from we basically run our build logic and then remove that integer from the array, and thus the build queue moves down 1. And you can have up to 5 units in your build queue, which is an arbitrary number, but because we wanted to get to 45 units max, we didn't want you to just queue up 900 units. I also have a hard build cap of 45 units per player. If you try and build more than that, I just won't let you. That's pretty standard RTS methodology. But using this method, we can just iterate through the build queue until it is empty. The building itself is relatively simple. To build a unit, we feed that integer into a case switcher, which, if you know any code logic, case switcher is literally case 1, case 2, case 3, do this logic. And so we have different logic based on the unit you want to build. And we check to see, 1, if we can afford the unit. If you can't afford the unit, then we don't let you build it. We just iterate through the loop again until you have the money. But if you can build the unit, we then use a sleep command, because this is an async routine, that is the build time. And we have a UI, you can see it up there, that's also ticking down, showing the time until the unit is built. And once that time has expired, we spawn the appropriate unit at the end with an NPC spawner device. One note, so as we needed 1 spawner device per unit type per player, each production structure does in fact have 6 spawners, which is a little heavy. But we wanted the factions to look different. We didn't want you to have the same looking units on each side. It's actually, if you know Fortnite at all, this is Fish Sticks versus Peely, because I'm Team Peely, and I wanted Peely in the game. I own a lot of Peely stuff. But yeah, that's basically how we built out a production logic. And that is a lot of, here's how we did stuff in Verse Talk. So I want to hand back to Florian for something a little more fun.
A little bit more visual.
Visual design.
So, let's talk about the visual design. So in fact, I told you before that the camera proxy is the center of everything, right? Which is still true, but I also did kind of lie to you because we are actually using because so what I wanted to have, I love this miniature look, right? So this tilt shift look, where stuff was just blurred at the bottom of the screen, right? And the further you get away in the background, also blurred. And that was actually not that easy to accomplish. So let's go to this slide. No.
Very hard.
Yes. Yes, it was actually really hard because it has a few implications, right? I started turning the camera, which meant that the selection box didn't fit anymore and stuff like that. So we needed to work around that. Because obviously, if it's like completely top down, then my tilt shift does nothing, right? Because everything is on the same layer, mostly. So what you can see here is, and I will explain in editor in a second how it works. We actually have autofocus, and we actually have a zoom in there, which is pretty amazing. And I will go to the editor now. Okay, so how do we start this? So blur, right? Controls over here, and this is where we're also now going a little bit more into detail about what
this explains the 900 devices we have under camera.
Yeah, and why do we have them? Again, so the camera proxy is the center of your camera, right? But that didn't really line up. But let's start this way. So fixed angle camera device, right? As I said before, we are using that one. As I'm coming from Unreal originally, I was like, yeah, cine camera, right? Let's just add depth of field. Awesome. Nah, you can't.
Oh.
So there's literally nothing, right? So I was like, okay, how do we solve that? And Sam was in the, like, we had a couple of days where Sam was really like, oh, let's drop the feature. Let's drop the feature. And I was like, no. Just let me cook. We'll get that done. So
I didn't believe, but now I do.
For the longest time, our talk was not called Florian and Sam are building a real-time strategy game in UEFN. It was called Florian and Sam are attempting to build. So basically, and we have a lot of effects, and I can get into the others at the booth. But essentially, this is the tilt shift effect. So, awesome editor. So I was like, okay, how do we do that? Like, right, let's start, let's do a shader, right? Post-process material and so on. So this is my little shader, and let's ignore the bottom part for now. Blur, right? How do you blur? Well, let's just write a custom code. Nah, you're also not doing that in UEFN. So I was like, okay, let's recreate Nuke. The way this works, again, we are in a 32-bit, so that's important to know, important to remember the renderer. So I'm taking a scene texture, right? This is just scene texture, post-process input 0 is my rendering, right? I can actually take that, in this case 8 times, and then edit on top of each other. And that obviously gets me a rendering which is 9 times as bright, right? So you need to divide by 9. And all of these renderings are, and this is just a note from a convenience note that I took from UE, and you can just get it. It's in starter content. But essentially, I'm just adding to my UVs, to my screen position UVs, right? I'm just adding numbers, and I'm pushing the renderings around, adding them on top, dividing, and we have our output result, which is our blurred image. You can also see that here. We also have our non-blurred image, right, and just lerping them and using that. So mask, right? How do you mask that? Because obviously you have areas that are sharp and areas that are not sharp. I started out with a simple texture, which kind of serves the purpose because black is sharp, right, and white is not sharp, but then we ended up like, oh, we have trees, right? And we have actually large trees, and we have differences in terrain. So
someone designed a map with multiple terrain heights.
I'm sorry, that did bite me a little. So we had to compensate for that, right? So a mask is just not good enough. So I tried a few things, and this is just me with like doing stuff and masking out top bottom. Doesn't really work. But we do have a depth channel, right? So we can use that depth channel, and we can use it to control. And I did a debug. Where's the one? Oh, for presentation, it's great. It's checked out on the booth. Let me see. So show debug is okay. Let me go here. So we have a post-process volume, so I will just plug it in here because right now for demonstration purposes, because it is unbound, so you guys can actually see something. Yeah, okay. This is
a different Florian on the booth must have checked it out.
This is great. Okay, so
we have video. We can show the video version.
Yeah, let's do. Yeah, wait. What are you doing, UEFN? Stop it. Okay. So let's just copy that and let's just edit here. Doesn't matter. No, I don't want to check in. Asset reference. Here we go. So this is what happens, right? So we have our depth channel, and you can see the focus area is shifting with like where I am, right? The height and so on, the difference. And also that means if I'm moving the camera from a lower altitude to a lower one, from a higher altitude to a lower one, then the focus area doesn't work anymore, right? So we needed to adapt that. And to do that, here's my material. I'm just using a remap value range, right? I need 0 and 1. And then I have my input low at the top and my input high at the top, and also here. Wait. Yeah, and I can control those, right? We can control those. So the way you control those is either through sliders or in gameplay through a material parameter collection. That's literally the only way we can get like gameplay interact with your material or with your shader. So this one is actually controlled by a sequence, and you can see that. So this sequence is controlling the focus distance, or is controlling those values in the shader. So, but how do we now like control this the sequence, right? So for that, I created...
This is the bit where I nearly cut the feature right here.
You're like, yeah, don't do it. No. So again, sorry for my naming. It's called Sequence Position Controller. This device, basically what it does, it's just controlling the position in the sequence, right? That's literally the only thing that it does. But I need a proper, like I need to get the distance, right? I need to get the height. I need to get those differences. Otherwise, I will just, it doesn't work, right? Because I need a way to control that. And I can't turn that off. I love it. Sorry. So let's go back to this one and let's just get rid of that. Okay. So how do we control that? Well, the only thing that I could think of was a raycast. So how do we get a raycast? We get a raycast with control rig. So we actually, and this is this little pyramid on top here. So we have a linear prop, which is basically just raycasting. It's raycasting down here at the bottom, just straight down, right? And so just showing you the raycast. So yay, actual raycast. Awesome. And this is, again, this one is parented to the camera proxy, so it's always in the middle. The way the control rig works is literally just input, right, and then tracing to the bottom, or in my case, 5,000 units. Doesn't matter because it was big, was enough, and then setting the other prop to that position. To that position. And I can obviously get that position, right? Normalize it, clamp it, do some math and whatever. And then I can use that difference to control my sequence. And now we had this situation where, because I was using instigator only and in the cinematic sequence device to control the effect per player, and it kind of worked, but not 100% reliable.
Not 100% reliable.
So he was controlling my stuff, I was controlling his stuff, so it drove me insane. So we separated everything. We have two different variables. We have two that are controlled by different sequences. And you actually switch in the material. So we also have two material instances, and you tell them is it player 1 or is it player 2? Because it's different hit results, right? We have different hit results per player because obviously he's in a different position than I am. And we have two post-process volumes also attached again to the player, to the camera proxy. And funny enough, the player 2 is actually like 100 units higher. You don't notice if you don't know. And we have two post-process volumes, one per each player, very small. So I don't get his effect and he doesn't get mine because obviously post-process volumes are not exclusive. So it only really can happen if two players are at the exact same time, at the exact same position, and one is zooming out and one is zooming in, then they would overlap. So that was good enough for us.
Okay, and back to me. So I can do none of that. and I wasn't sure if we could do it at all. But yeah, so let's talk now about why Florian had to do all that, because someone designed a map with multiple terrain heights. That person was me. So I'm going to talk really briefly about map layout before we run out of time. So RTS maps need a very precise layout. If you ever played a strategy game, you know that your map layout needs to conform basically very smartly to a grid usually. If it's a symmetrical map like this, you need both sides to be the same. Otherwise, one player has an advantage over the other, and then your game is unbalanced, and then people send you death threats on the internet. So you generally want to avoid that. It's not saying that ever happened to me. So terrain sculpting, like Unreal and UEFN have great world building tools, but it isn't necessarily the best method for prototyping this out. Yeah. So what I did was I built basic terrain pieces with cube grid. You can see there at the top, that's part of the modeling tool. Lets you define an arbitrary grid and then extrude from it, push in, push out, and build out basic geometry. So I could use cube grid to measure out the map and test the heck out of it to make sure that it was actually good enough for what we wanted. At that point, I built some basic gray box geometry, which you can see at the bottom. And it's deliberately incredibly ugly because then someone talented has to make it look good. And overlaid the geometry over my cube grid layout and then tested it more until I was happy with the layout, till I thought it was balanced and fun. It did mean that we ended up with multiple terrain heights, which meant I broke the tilt shift effect, and thus Florian had to work really hard for 2 weeks and, not sweat at all. Yeah. But once we got that layout done, I basically could throw it over the fence to Florian to turn it into something that doesn't look pig ugly like that. And so we went from this gray box layout to this very beautiful final art that Florian did. And I will switch back to you to talk a little bit about that. We have to go fast as we're running out of time.
Yes, I will speed up. So landscape, obviously we're using foliage instances for all the trees, for the rocks and so on, which also had its own challenges in terms of navigation for the NPCs, and because we're so far away, right? And we're doing something very alien to the Fortnite concept. So there was a lot of stuff to do here, also in terms of like, is this, like, can a character step on this geometry and so on, and these kind of things. Everything in here, like, and it's hard to see on the projector, but there's like so many animations, and there's wind, there's wind blowing the snow on the landscape and so on. What we did, what was really key is we are using, so this is not the Fortnite lighting, we're using the environmental light rig, because what that allowed us was full control over also how it would look on mobile phone and on, I'm not sure if I
That's a Switch 2.
Yes, it's a Switch 2.
I'll say it, they can get mad.
Because you have that control, right? And the key here was just substituting lumen, because you don't have lumen, right? You substituted with an HDRI to get all your lighting colors and your stuff back into the system. In terms of optimizing for mobile, right? LODs, take care for your textures and so on. Sorry, need to go fast. We do have material switches, so in the materials, so we are checking, we are basically in the material checking which device are you, and are using, if necessary, a different set of variables and stuff in the shader. And yeah, that's it.
And so what did we end up with? As I can hear the applauding next door, so it was our cue to end this talk. So the end result was something that I like to say is definitely not Fortnite, built in Fortnite. And we promised you a longer trailer. Here you go. With rocking music. I think I lost this match.
Yes, you did. And then you started cheating. I couldn't capture your buildings anymore.
It was a viable strategy. I have no idea what you're talking about. Yes, that is my base being destroyed. RIP my base. Yeah, I was crushed.
We
did it, folks.
Yes.
Here's
Thank you so much.
So this QR code will take you to my link tree, which will link to an Epic Developer Community page with like access to the boilerplate code, references to all the devices we built, and I'm hopefully going to update it with more information over time. So yeah, check that today, and then check back whenever this talk comes out on YouTube, and hopefully we want to build a lot more information so you can see more of how we built it. We will be at the booth at 11 onwards if you want to open up our hideous verse code and make you look at it. But thank you so much for coming. We really appreciate it.
Thank you so much.